When dealing with electric baseboard heat and load calculations, specifically concerning NEC section 220.30, it is necessary to determine whether to apply subsection 3 or subsections 5 and 6. Subsection 3 is generally applicable when the heating is designed to run at full nameplate value. The decision of whether to use the optional calculation or the standard calculation hinges on several key factors. Firstly, are there plans to load balance the electrical loads between the two units? If not, it is generally not recommended to use the optional calculation. Load balancing involves distributing the electrical demand evenly across the available phases or circuits, which is crucial for accurate optional calculations. Secondly, the type of equipment being added plays a significant role. If it is just a new dryer, the optional calculation might be more suitable. However, if you are adding substantial loads like a second dryer, a central air conditioner, or a hot tub, the optional calculation becomes less reliable. The optional calculation is most accurate when only a small, predictable load is added. Thirdly, consider the cost of upgrading the electrical service. If upgrading the service presents a significant financial burden for the homeowner, then the optional calculation might seem more appealing. However, weigh the potential risks and inaccuracies against the cost savings. Finally, consider the age of the house. Older houses often have hidden electrical loads or outdated wiring that can affect the accuracy of the optional calculation. Undisclosed or unaccounted for loads can skew the results of the optional calculation, leading to an undersized service. It is always advisable to err on the side of caution and use the standard calculation method, especially when dealing with significant electrical loads. The standard calculation method is the standard for a reason. It provides a more conservative and comprehensive assessment of the electrical demand. In this scenario, there is an existing duplex with a total of 18,200 watts of electric baseboard heat, along with 2 ranges, water heaters, dishwashers, and other appliances. The owners plan to add 7,500 watts more heat, increase the square footage, and install a second dryer. This results in a standard load calculation of 253 amps for an existing 200 amp service. While the optional method might reduce the calculated load due to the heat being taken at 40%, it is essential to carefully evaluate the factors. The concern is that the two methods can produce significantly different results. Given that money is not a primary concern for these individuals, the safest approach is to proceed with the standard method and upgrade the service to a 320 amp meter socket and disconnect. Upgrading the service ensures that the electrical system can safely handle the increased load and provides a buffer for future expansion. Now, delving into the specific NEC sections mentioned, it's crucial to understand the context and application of each. NEC 220.30 outlines the optional calculation method for dwelling units. This method allows for a reduced demand factor to be applied to certain loads, such as heating and air conditioning, under specific conditions. The goal is to more accurately reflect the actual load imposed on the electrical system, as opposed to simply summing up the nameplate ratings of all appliances. NEC 220.33 pertains to electric space heating loads where the total connected load is calculated at 100% of the nameplate rating. This is typically applicable when the heating system is designed to operate at its full capacity for extended periods. In contrast, NEC 220.35 and 6 provide demand factors for heating and air conditioning equipment based on the total connected load. These sections allow for a reduction in the calculated load, typically around 40%, recognizing that these appliances do not operate at their maximum capacity continuously. To determine whether electric baseboard heat falls under 220.33 or 220.35 and 6, assess how the heating system is designed to operate. If the baseboard heaters are intended to run at full nameplate value to maintain a constant temperature, then 220.33 is more appropriate. However, if the system is thermostatically controlled and cycles on and off, and it is part of an overall heating and air conditioning system with diversity, then 220.35 and 6 might be considered. Given the addition of 7,500 500 watts of electric heat, a second dryer, and increased square footage. The standard load calculation indicating 253 amps on a 200 amp service raises a red flag. Relying on the optional method to artificially reduce the calculated load can be risky, particularly if the assumptions underlying the optional method are not fully met. While the optional method might initially seem appealing due to potential cost savings, it is essential to prioritize safety and long-term reliability. Upgrading to a 320 amp service, as suggested by the standard calculation, offers several advantages. It ensures that the electrical system can safely accommodate the existing and added loads, reduces the risk of overloading the service, and provides future capacity for additional appliances or equipment. Additionally, consider the impact of non-coincidental loads. These are loads that are unlikely to operate simultaneously, such as the electric ranges, water heaters, and dishwashers. The optional calculation method often incorporates demand factors to account for non-coincidental loads, but it is crucial to assess whether these demand factors accurately reflect the actual usage patterns. Moreover, older electrical systems might have deteriorated insulation or undersized conductors, which can further compromise their ability to handle increased loads. Upgrading the service provides an opportunity to inspect and upgrade the existing wiring, ensuring that it meets current safety standards. When evaluating the optional calculation method, carefully consider the following factors. First, the accuracy of the load data. Ensure that the nameplate ratings of all appliances and equipment are accurate and up to date. Second, diversity of loads. Assess the extent to which different loads operate simultaneously. If there is significant diversity, the optional method might be more appropriate. Third, future load growth. Anticipate any potential future additions to the electrical load, such as new appliances or equipment. The upgraded service should have sufficient capacity to accommodate future growth. Fourth, safety margins. Incorporate a safety margin into the load calculation to account for unforeseen circumstances or unexpected load increases. It is important to consider that the NEC is a minimum safety standard. Designing an electrical system that exceeds the minimum requirements provides an extra layer of protection and reliability. Furthermore, consult with the local electrical inspector or a qualified electrical engineer to obtain guidance and ensure compliance with all applicable codes and regulations. They can provide valuable insights and expertise based on the specific circumstances of the installation. Remember that electrical work can be dangerous. Always prioritize safety and follow proper procedures to avoid electrical shock or other hazards. If you are not qualified to perform electrical work, hire a licensed electrician. Before making a final decision, carefully weigh the advantages and disadvantages of both the standard and optional calculation methods. Consider the factors, consult with qualified professionals, and prioritize safety and long-term reliability. The peace of mind knowing that the electrical system can safely handle the load is invaluable. Finally, document all calculations and assumptions made during the load calculation process. This documentation can be helpful for future reference and for demonstrating compliance with electrical codes and regulations. By following these guidelines, you can make an informed decision about whether to use the standard or optional calculation method for electric baseboard heat and ensure the safety and reliability of the electrical system. In the context of the renovation project in Camden, Maine, the additional 7,500 watts of heat plus increased square footage and the second dryer presents a significant load increase. Given the existing electrical infrastructure and the homeowner's willingness to invest in a safe and reliable solution, upgrading to a 320 amp service using the standard calculation method appears to be the most prudent course of action. In addition to the load calculation methods, also consider the proper wiring methods and overcurrent protection for the electric baseboard heaters. Ensure that the wiring is sized appropriately for the load and that the circuit breakers or fuses are properly rated to protect the wiring from overloads and short circuits. Also, follow the manufacturer's instructions for installation and wiring of the baseboard heaters. A proper installation can lead to overheating and fire hazards. Electric baseboard heaters should be installed in accordance with NEC Article 424, which covers fixed electric space heating equipment. This article provides specific requirements for wiring methods, overcurrent protection, and clearances for electric baseboard heaters. When upgrading the electrical service, also consider the grounding and bonding requirements. Ensure that the grounding system is properly installed and that all metallic parts of the electrical system are bonded together to minimize the risk of electric shock. Grounding and bonding are essential for electrical safety and should be performed in accordance with NEC Article 250. Article 250 provides comprehensive requirements for grounding and bonding of electrical systems. It covers topics such as grounding electrode systems, equipment, grounding conductors, and bonding of metallic enclosures and equipment. Also consider the use of arc fault circuit interrupters, or ASIs, for the branch circuits that supply the electric baseboard heaters. ASIs are designed to detect arc faults, which are a common cause of electrical fires. ASIs can provide an additional layer of protection against electrical fires. ASIs are required by the NEC in many dwelling unit locations, including bedrooms, living rooms, and dining rooms. Check the local electrical codes to determine the specific requirements for ASIs in your area. Also, consider the use of ground fault circuit interrupters, or GFCIs, for any receptacles that are located near water sources, such as in bathrooms or kitchens. GFCIs are designed to protect people from electric shock by interrupting the circuit when a ground fault is detected. GFCIs are required by the NEC in many locations where there is a risk of electric shock. When selecting electrical equipment for the renovation project, choose equipment that is listed by a recognized testing laboratory, such as Underwriters Laboratories, ORL. Listed equipment has been tested and certified to meet safety standards. Also, choose equipment that is appropriate for the application and that is properly rated for the voltage and current requirements of the electrical system. After the electrical work is completed, have it inspected by a qualified electrical inspector. The electrical inspector will verify that the work was performed in accordance with the electrical codes and that it is safe. An electrical inspection is an important step in ensuring the safety of the electrical system. Keep a copy of the electrical inspection report for future reference. When planning the electrical renovation, consider the overall layout of the electrical system. Ensure that the electrical panel is located in an accessible location and that there is sufficient space for future expansion. Also, consider the placement of receptacles and switches to ensure that they are conveniently located and that they meet the needs of the occupants. When running electrical wiring, follow proper wiring practices. Avoid running wiring through walls or ceilings where it could be damaged. Protect wiring from physical damage by using conduit or other protective measures. Also, ensure that wiring is properly supported and secured. When making electrical connections, use approved connectors and terminals. Ensure that connections are tight and that they are properly insulated. Loose or poorly insulated connections can cause overheating and electrical fires. Also, when working with electricity, always de-energize the circuit before working on it. Use a voltage tester to verify that the circuit is de-energized before touching any wires or components. Working on energized circuits can be extremely dangerous and can result in electric shock or death. If you are not comfortable working with electricity, hire a qualified electrician. Electricity is dangerous and should only be handled by trained professionals. By following these safety precautions and best practices, you can ensure that the electrical renovation project is completed safely and successfully. Remember, safety is always the top priority when working with electricity. The existing duplex with 18,200 watts of baseboard heat ranges, water heaters and dishwashers already has a considerable load. Adding 7,500 watts of heat and a second dryer adds to this, so do the calculations carefully, keeping future expansion and improvements in mind.